jog is where you do your setup. So start and jog, and then we see we've got TSM, set, work, offset, measure, workpiece, measure, tool, position. So TSM, tool, spindle, machine type stuff. So if I want to change to a tool, I just go T, select tool, and this is the tool list. So I just find the tool, maybe I want to change to the shoulder mill, I hit OK, we see that it's entered in here, and then all I do is I hit cycle start.
Goddamn.
That's not my drill. I know. I saw that.
And right now this is doing a longer tool change. So that chip fan we have what's in what's called a locked position. So that chip fan we have currently set up to return to the same tool pocket every single time. So it had to return that one first. That's not the default mode of operation for this machine. The default mode of operation is the actual number of tool pocket in the turret is almost irrelevant. So it's not like you're calling tool 1, tool 2, tool 3. The chip fan could move between 1, 17, 32, whatever. So I'll show you what that looks like changing to a non-locked tool. So right now we've got the Shellman mill in there. That might be a locked tool. We'll see about that here in a second. So I'll change like a 1/4 inch chamfer mill. Let's see. Yeah. So this is a locked tool as well. We're in the debate right now whether or not to lock all the tools or to unlock all the tools. It kind of throws me off a little bit because when you're looking in the tool magazine, you know, you're looking at the number, but it's not in the number that you think it might be because it's floating and it mixes it up all the time. So that's why I locked a few certain tools to begin with. So right now, for example, we've got the chamfer mill. It's loaded in the spindle and it was in pocket 12. Well, let's do another tool change. So let's change to like the probe there. If I change to the probe, so it's just going to move to the probe, and then it's going to put the chamfer mill where the probe was most recently. And that's just to make tool changes efficient. So again, the numbers on the turret by default are non-locked, so your tools will float between positions. So that being said, it is a little bit easier to read your tools because when you create a tool, you give it an actual name, and you can name it whatever you want. This is also how you call it in a program. So it's not like you're calling T1 M6. You're literally doing, you know, T 2-inch shoulder mill. That's how it looks in your program.
Yeah. Are loading tools up to you or us? Because I ain't never loaded a tool up there before.
Say that again?
Is loading tools up to you or us? Because I ain't never loaded a tool in there before.
No, you guys will need to load tools. So as far as loading a tool, it's pretty basic. So let's grab a fresh tool and show you kind of. So there's a couple ways you can do this. So what I recommend is, first of all, you clear the tool pocket. So if I just tap in there, this number pad comes up. If I just type in 0 and I change to tool 0, what that basically does is it returns the active tool to an empty turret position and leaves the spindle empty. So there's no tool loaded in the spindle. So tool 0 is empty spindle basically, right? So let's say I wanted to load this tool and I needed this for a program. Well, what I actually recommend is building the tool first. And if you go to the tool tab, so the second one there, and then you go to the very bottom here, see that's location 30, so that's the end of the turret. I can build a new tool in an empty position. I don't have to build a tool in an active position. So if I go there and I say new tool, I get this list of options. And these are the favorites. But if you want to look at every potential option, you've got all these menus to look at. So that's cutters, that's drill, that's turn tools, that's specialty tools. So cutters probably for the majority of things. And they've got weird German names to them. So a lot of this might not make sense, or some things might not make sense. For example, there's no chamfer mill. You have to use like a center drill is currently the best option that we're aware of. So, and that would be under the drill tab, even though it's a chamfer tool. So like milling tool versus end mill, those are probably functionally the same, but you know,
I hated that.
Yeah, so try and be as accurate as possible. So in this case, I'll use like an end mill.
That's right.
And I'll give it a name. And you can name it whatever you want. That being said, try and use a semi-standard form of nomenclature, but I'm also not going to write a paragraph to describe this tool, right? So I like to use abbreviations. So like solid carbide, SC, indexable carbide, IC, things like that, right? So I'll take a quick measurement here. Looks like, you know, 1.25 inches sounds right.
Let's go.
So 1.25.
Calibrated eyes.
And then, you know, you can do uppercase, lowercase. Let's say inch. And then you could say maybe like 5 flute. And you don't have to describe the tool too
6,
much.
I thought.
I could just say, you know, corn, cob, rough, for end mill, right? Because a lot of this other information you actually see in the rest of the tool offsets. So I started writing like number of flutes in there, but that's actually a value in here, N. So this is a 5 flute, so N is your flute number.
Oh, 6.
No, you're right, 6. So
Yeah.
6. And then this is direction of rotation, so by default it's going to be clockwise, but if you have a left hand cutting tool, that would be counterclockwise. If you have a probe, you turn that as no rotation, right? Or if you have a non-rotating tool other than a probe, like a right angle head or something like that, because if you don't do that, then it's going to spin it up, and that's a bad day. You'll break stuff. Also, so our options here, so 1, 2, 3. So option 1 is flood coolant. Option 2 is, I think, air blast. So external air blast, not through spindle air, but it's air blast. And then option 3 is through spindle coolant. So CTS, coolant through spindles. And that's, you only want to engage that if you're using a tool that has proper through spindle coolant, and then you got to make sure that your pull stud is a through coolant spindle pull stud. So this one does not have a hole in the middle of it, and this tool is not even set up for a through spindle coolant, so we would not want to make sure that that's not engaged when this tool is active. But again, it's up to the tool, so not every drill is going to have through spindle coolant. You only use through spindle coolant when you have a through spindle coolant tool and pull stud. Both of those have to be correct.
So it's not air in.
Just coolant. Yeah, so just through spindle coolant, and then we've got external flood coolant and external air. So we do have air blast. We also have washdown. So if we look inside here, there's manifolds that go around the periphery of the machine on the bottom. And right here. And then we have M08, that's your flood coolant, so don't recommend doing that with the door open unless you know what you're doing. And then we've also got coolant through spindle. So the coolant buttons are at the middle, at the top there. Yeah, so just to show you what that looks like, you guys saw the washdown, but here's coolant through spindle. Coolant pressure low. So that's why we only activate that when we have the proper tool set up for it. Yeah, because we don't want to damage the spindle, so we don't want to back up with pressure or trying to eke out the size of the taper or anything like that. So you don't command like M08, which you're used to on a Haas machine. Coolant turns on depending on how you've checked these boxes in your tool offset library.
Got it.
Does that make sense?
Yeah.
So when you call a tool, as soon as you engage the spindle, it's going to look, okay, are you using flood, air, or through spindle, or neither? And then it's going to turn that machine function on. So make sure you have the proper function set here.
Okay.
And then M8, you guys are used to that. That's your washdown. So we've also got chip forward and reverse. So this is the chip conveyor. So typically you're going to run it in forward, and that's going to take the chips that you now washed down into the bottom, and it's going to bring it up and out the conveyor. And then just make sure you don't leave that on forever. So look at the little LEDs above the buttons and make sure to turn the button off at the end of the day. So you don't want to just run the chip conveyor forever. And it might even auto time off, but I'm not 100% certain on that one. And we've also got air blast. You can manually toggle that as well. So right now we're not really doing much with it, but we can use that for other functions as well.
Where does the air come from?
What's up?
Where does the air blast through?
Okay, so where is it at? Purpose that for some special spindle gripper type tools. So we might make an air bypass because this doesn't have through spindle air. So we might make a bypass that couples to the spindle nose, and that way we could use like essentially a pneumatic gripper as a tool in the spindle to like pick up and move parts around. But that'll be later. You're jogging. So you can do hand wheel run. This is your hand pendant, so this is pretty handy because a lot of times if you're in the machine working on stuff, you can use this. This has, very similar to a robot, these dead man switches on the side. On the mill, it's 2 dead man switches. On the lathe, it's just a single dead man switch. So if I want to jog the x-axis, I have to toggle it to the x-axis, and then I hold the switch. Your jog increment is here. So bigger number, bigger move. So if you want small number, that means move small. If you got the X100, that's going to be a big move. And again, it's every click of this is moving that increment. So you can also you can jog manually. So if I have X highlighted and I hit the plus sign versus minus, and if I want to go really fast, I can hold rapid at the same time. But it probably limits it when you have the auto door open. So if you close the door, it'll allow you to rapid position.
So nice to see it.
With what?
No slot, brand new.
Yep, she's new. Let's not destroy her. Let's keep her maintained. Same thing, we have the 4th
Treat her
axis.
nice.
So you have XYZ jog, but you also have the 4th axis. So you can rotate that, index it, do whatever you're doing there. And just the same, you can do that here as well.
Cool.
So that chuck is not powered, so that is a manual key. Here's our key. Please don't lose this. If we lose it, it's not the end of the world. We can find another one or make another one. But just keep it here for now.
I'll leave it in there.
And then we got an air gun. You've also got a wash down hose here. Just make sure that you know what you're doing when you're doing this, and you're probably pointing it inside the machine before you turn any coolant on. And then don't make the mistake I did where I had a side door open and then turn the coolant on and have it spray out all on the side.
Yeah.
So make sure your side doors are closed before you do a deep wash down, especially manually.
Yeah. Some of the side doors have locks on them after you push them open. Where's the key for that? Is that something that we have access to?
It might be one of these keys. It won't be the one that you have access to. So this is a mode key. So basically these different colored keys, if you remember from last quarter, Run My Virtual Machine, key switch 1, 2, 3, 0. So that basically controls what you're allowed to do at those different modes. So 3 is kind of the most permissions that you can do, and then you're pretty much able to do most things aside from like manufacturer parameter changes. You need special passwords for that. And then if you're in production mode, you just want a button pusher to load parts and run programs and do nothing else, so they can't mess anything up. You'd give them like 0 or 1 position, and you would take the physical key. There's also technically a way to set up user passwords, so long term we'll probably end up doing that, where basically you have to log in or badge in, and that's unique to you, and then we unlock certain permission levels based on what you're doing at the given time. And you can also do that per program. So you can set your programs to have certain permissions or passwords tied to them. So that way only you're the one who can mess with them, things like that.
Cool.
Yeah.
In the off chance that we do have to do a power cycle on this thing, do we have to rehome the axes?
So this machine always knows where it's at, so there is no homing procedure needed.
Ever?
Yeah.
Okay.
Yeah.
That's
Maybe,
really cool.
maybe in a recovery, but in normal operation, without any major crashes,
Damn, it's
if
not
we lose
fucking
power, you power cycle it, you just turn it back on, and then no homing routine necessary.
Okay, because I saw the alignment arrows.
So we said corn cob, rough end mill. So I'm going to put a length in here, and I need to put just a rough value. And we need to put a rough value in here because we have the automatic tool probe on the table in the back left corner there, but it needs to know a starting length to be able to do things properly, as well as a starting diameter. So how you get a rough length is you basically measure from the back of the flange to the tip of the tool, and that's your rough gauge length. So right now I'm getting, a little under 6.5, so I'm just going to say 6.5 inches. And you enter this as a positive value.
You mean
I'm going to say 6.5 length value, and then diameter, you said was 1.25, right? And this is why you don't necessarily need to include all the details in your name, because we see the length, the diameter, the number of flutes all right there, right? And then if I want to, I'm not going to do it for this because it's not really a real tool, but yeah. And then, so I've built it out here, and these are just rough dimensions, give it a name. Now I'm going to hit load, and by default, it's going to look for the next available location, but if you have a specific location that's not currently occupied that you want to put it in, you would do this here. But for now, because it's all floating for the most part, I just plugged it into 10. So we see that the tool in theory is in pocket 10, but it's not actually physically in there. So at this point, what I recommend doing is you close the door, you go to TSM, you change to that tool, and then we pop it in there. So we go to machine mode, select tool, and it already has that selected. Tries to do things intuitively, so it'll pull up whatever you were using last most of the time. Hit OK, cycle start. It'll move the pocket 10. It assumes, because it's in the offset table, that there is a tool loaded in there, but there shouldn't be. And if there is, we've got a problem there. So if you run into that situation, let me know. It could be that we lost home on our tool turret or something like that. But we open the door and we load the tool just like normal. Now, if you're struggling and the tool's like kicking back at you and it doesn't want to go in, take a step back, do it the way I'm going to do it. So don't put the tool in there first, hold the button and give it a second, then put your tool in there and then let go. And then you go struggle. Yeah.
So is it keyed like dimple to dimple side, or?
I don't think it matters too much.
Okay.
But ideally, yeah, your dimple side would be this side facing you. Because this is basically, this is the tool, this is the keys in a clock position for a tool change.
Okay.
So it's kind of angled like that on the spindle nose.
Okay.
Yeah, but that angled front left key, that would be your dimple.
Dimple side?
Yeah.
Okay.
And now our tool table matches, right? So we've got the corncob rough end mill currently loaded in the spindle. We've got rough measurements. So from here, we could actually do true measurements with the tool. So you can close the door, go back to TSM or machine mode. We got measure tool. So you can do length, diameter manually. Don't really recommend that because we have a probe. So we got length auto and diameter auto. I would start with length auto. And this is pretty basic, you know, check teeth individually, and don't need to for this one. Tool offset auto, DV, that's basically if you've got, if your cutting point of your tool is not on the outside edge and you need to compensate for that. So this visual here shows you basically that from the outer diameter to the actual cutting tip of the insert, in this case the shell mill. We don't have many tools that need this, so most of the time it's going to be a V. And then we just hit cycle start. And what it's going to do is it's going to bring it over and it's going to run it down. And so you guys remember on the Haas how we like to have you guys essentially run things in reduced rapids. So the equivalent to that here is you've got this dial for your feed rate. And we can see that I can turn it all the way to 0 and it stopped motion. So if I turn it up to 1%, it's moving. Your position screen here, so right now this is your active work coordinate system, whatever that is, G54, G55, and that's the position relative to your work coordinate system. This is your distance to go. So it's the same exact way that it works on a Haas, so you don't have to pull up a separate screen or only look at one. Your distance to go is always there. And this is basically telling us, hey, it's going to move, another negative 6.6 inches in Z before it continues with the rest of its program. So that looks about right to me, so I'm going to crank it back up to 100. But if you're ever unsure about a program or proving it out, this is what you do. You lower your feed rate and then you go slow, right? You look at your distance to go and you go slow.
The fact that it's spinning.
Oh, spinning?
And we can see here that it adjusted the length offset for our tool. So this is the active tool, corncob rough end mill. Originally I put for L 6.5. The reality is 6.4622, right? So that updated. And we can do the same thing for diameter as well. So if we go back, measure tool, diameter auto, same thing here. Do we want it to check teeth individually? Do we want it to have any particular, compound offsets, anything like that? Then we just say cycle start. And if you're concerned about it moving in a certain way, just reduce your feed rate and crank it up. So this is what we want to do for the majority of our tools. We shouldn't be setting tools manually. We're using the probe. Yeah.
Is the probe a consumable then?
Say it again.
Is that probe a consumable then, the little black tip? If you're touching it with a spinning end mill, I feel like it would be.
So what direction is it spinning?
Oh, it's spinning in the opposite direction.
It's dragging up on the back side of the flute, not engaging the cutting edge of the flute.
Got it. Okay.
So this is why it's important to have the correct direction of rotation for your tools as well, because I didn't command it what direction, right? It looked at the tool data and then said, hey, this is a clockwise cutting tool, so I'm going to spin it counterclockwise when we go to probe.
Oh, okay, so you're saying that we gotta do clockwise first while we probe and then flip it back to counterclockwise?
Yeah, so your tool information is very critical.
So
whatever see that direction right there? It's basically looking at that in your table, and it's going to do the opposite of that when it probes.
Got it.
So make sure that this is accurate. Your tool offset, very important. Yeah. So, and again, this is also referenced in your programs. Your programs don't say M8 to turn coolant on. They just look at whatever checkboxes are here, and that's what it engages when that tool starts to be active.
Cool. So if you were to do the probe routine and you had those on, it would try to run coolant while probing?
No.
Or different?
No, because the probing macro that's built into the machine doesn't do coolant. Okay. It doesn't engage the coolant, yeah. So there are internal like background things that run, we just never see them. If we're doing a cutting operation, so we're engaging the spindle, then it's going to activate those. But in the probing, in the in-machine built programs for the probing routines, it doesn't run coolant.
Are we going to be building a cover for the probing tool at all?
No plans to currently. I'm trying to find one that actuates automatically. Okay. So I don't want a manual cover. I want one that we can trigger.
That makes sense. Okay.
And there's little things like that that you got to worry about. So if that collects a bunch of chips on it, that can throw off the probe essentially. Have it do an incorrect trigger or an incorrect length on your tool. Same thing with the part probe. So if you get chips that are stuck on the ruby tip, and that gets between your part and the probe tip, then you'll measure position or dimension incorrectly. So there's tricks that you can do where like you air blast the tip of the ruby tip of the probe and things like that to clear it off before you do a probing routine. All little things that you have to figure out once you get into like really high-end automation on these types of machines. So that's basically how you load a tool. Let's say you wanted to take the tool out. Where's it at? Okay, so we gotta go to TSM. So first you gotta remove it from the spindle. So again, tool 0. Second start. In the tool offset table, you gotta find it, corncob rough end mill, unload. So that takes it out of one of the active 1 through 30 pocket positions, puts it down on the list here, and then just make sure to take it out. But at the same time, we did kind of things in reverse here. So ideally, we just want it to be. There is a way to unload it. So I gotta reload this. I gotta walk through this again. Confusing myself, confusing you guys. So I'm going to load this. We're going to do a tool change there. And we'll.
So you said take tool out and then go ahead and tell it that it's no longer in the pocket?
Yes. Oh. Yeah. So basically you have to take it out while it's active in the spindle, but then you have to unload the tool from the spindle, and then you, by doing like a T0 or changing to a different tool, and then you unload it from the offset table. A little bit procedural, so but basically here's what that looks like. So if you're struggling with loading or unloading tools, don't. Just take your time, hold the button, give it a second, and then it'll come right out, or hold the button before you try and jam it in there, and then release it, and it loads right in.
Are the keys colored?
Say it again?
It looks like the keys are colored. Yeah. Like 2 separate colors?
Yeah, it might be black. Looks like it, yeah.
Does it find its way in the right spot, or you still lighting it up like the other? I remember when
It clocks it to that.
What was that?
Spindle nose.
I remember somebody asked me how you look at the load.
Yeah. No, so you have to manually clock it. Yeah, exactly.
I told them, do not press this button that once the tool's in, that it basically releases it, and then they pressed it, and then the probe dropped.
Yep.
Okay, so technically on the tool offset table, we still see that the corncob rough end mill is loaded in there. So, and you see how there's no unload option here on any of these pages. So now we have to do what I was saying before. You either have to do a T0 or change to a different tool. And then from there, you can go back to the offset table and then unload it from the offset table.
Okay.
So in theory, you could have an infinite number of tools on the list. I'm sure there's a practical limit, so not truly infinite. And then just depending on whatever you do, you just load the right tool. So this is how you can do like shop-wide tools. So in your shop, if you have like 300 standardized tools, you could have them all listed in here. And then just whatever ones you're loading, you just click it on it, you load it into a pocket position, and then you physically load it. So now we go back to the offset table, we find that cord top, and then you can unload. That doesn't delete it from the offset table. Like we said, it's still there. And what's nice about that is all the information's still there, right?
Yeah.
So if it's a tool we only use once in a while, but we still use it, and we don't want it to take up one of the 30 pockets all the time, we can take it out, but we can keep all the information there, and then whenever we need to use it, we just load it back into a pocket.
So there is no limit on on the amount of tools that you can have stored on them.
As far as I'm aware.
Okay.
I'm sure there is a number
Like a
limit.
theoretical limit.
Yeah. Could be 1,000, 10,000, 100. I don't know. I haven't tested that limit.
Okay. Let's do it.
Yeah, put all the tools in there.
Say again.
Every combination of tool possible.
Shit that we don't even have. Fuck it.
20 hours later. There's
Yeah.
100. We only made it through like 7%.
Details of the tool, and I can just go to like details here, and we can see that there's monitoring data. So this is basically tool life management. And there's 3 different ways you can do it. So you can do it by minutes, you can do it by quantity of cycles, or you can do it by wear values. So you can basically trigger an alarm to either tell you to replace a tool or go to a sister tool, depending on whether or not it's triggered one of those 3 wear compensate or tool life monitoring values. So, and that's what this ST column is, I believe. So this is basically sister tool. So if I had like multiple tools that were a backup, you could say like sister tool, 1, 2, 3, whatever, and those would basically, when it triggers that tool life monitoring value and that tool's burnt out, it'll automatically input that sister tool and then run that into programs.
So then, can you have it set up where multiple tools are taking, like, multiple tools have the same sister tool?
Yes, you can have multiple sister tools.
I mean, can you have, I understand that you can have multiple sister tools, but can you have one sister tool for multiple tools? Like say you have half-inch end mill, and you just have like a ton of just half-inch end mills for some whatever reason, and it's in pocket 1, and you have it set where the end mill in pocket 2 is a sister tool for pocket 1, but then you also have one for 3 that uses pocket 2 as the sister tool. If that makes sense.
In theory, yeah.
Yeah. So then what ends up happening if like 1 uses it and then 3 needs it? Does it just try to go to the next value, like the next sister tool that?
No, it'll use the whatever sister tool hasn't triggered its tool life data yet. So,
Okay.
Yeah.
So it still goes off like tool life data
Yes.
per tool.
Yes.
Got it. Okay.
Yeah. And practically in industry, how they do this, typically you don't have like more than 2 sister tools. You basically just have enough sister tools to essentially do at most like an 8-hour cycle, to where like at the end of the day you start the cycle, you run it completely, you know that one tool is going to wear out during that cycle. Typically you're not running like more than 2 sister tools, and then you would just swap out the worn out tool when you came in the next day, and then make that the new sister tool, and you just sisters back and forth. So, to have you guys load a tool, set it from scratch, exactly like what I did, and that'll get you guys familiar with touching the buttons. Now, maneuvering around, delete that guy, okay, go here, there we go. Alright, who's up? Doing Run My Virtual Machine programming, correct? So we're not going to get to demoing that today, but that is still going to be the challenge for level 2. Utilize the open lab hours, utilize my availability during those open lab hours if you need help on programming the pond. And again, we can do lathe or mill. I'll leave it up to you guys. I will say the pawn definitely lends itself more as a lathe part than a mill part. But if you want to do one and you really want to do one, you can do that. So one thing that we want to have you guys do before you leave today on both machines is build a file folder. So we've got some fairly standardized folders here. So I've got instructor programs. So real quick, I'm going to make student programs or student progs. And with your file repository, you cannot use spaces. So you have to use underscores if you want to do that. So we got student progs in here, and I'm actually gonna, let's see if we can, properties, go, one underscore student progs. Follow our numbering here. So within here, make a folder for yourself. There is a character limit, just like with Windows, if you have a folder and a folder and a folder and a folder and a folder, and then your file name is 50 characters long, the total length of that file from like the root directory to where your file is stored, there's a limit to that. So like mine doesn't say Nathan Alexander Baker on my name, right? It's just Nate, and that way I can have a bunch of folders underneath there that I'm not meeting that character limit with. What's up? Yeah.
Yeah,
So
just
when you go to
your-
create it, so make sure you're creating
credit
it
card
within
number.
part programs, student programs. You go new, directory, and then you give it a name. Again, no spaces. Keep it short and sweet. Something that you will recognize, but keep it PC. Yeah. So let's do that, and then we're going to do the exact same thing on the lathe over there. So make your